Hello, welcome to Snoop Dogg Stoic with a mole-to-mole ratio. So we've got some practice problems here that we're going to work through. But just so you understand the connection to the graphic organizer, so we've already practiced moles to molecules and vice versa. We've already practiced moles to grams and vice versa, and we've kind of done a combination of this here. Now we're going to cross this other bridge. Today is just going to be focused on this here. Just moles of one compound to moles of another compound, also known as the mole ratio. And I've got some hints here for you. I've written in that it says mole ratio from your balanced equation. Okay, these numbers, when you do this step, it's going to come from your balanced equation. Okay, that's really important. So today we're going to focus on this, and eventually we're going to be able to put everything together. This is the only way that we can get from A to B, compound 1 to compound 2. So if you see two compounds, one compound switching to another compound, whatever, anything like that, you have to go through this step and you have to use your balanced equation to get there. So if I see one compound and another compound, I've got to do this step. So let's take a look at one of the problems. So I've already balanced these for you. If you need more practice balancing, feel free to go back to my balancing equations video. But right now I want to focus on this and not that. So here we are. This is my balanced equation for you. And it says how many moles of, so here, SiCl4 is used to make 20 moles of HCl. Notice that I have two different compounds. That's key here. Everything else that we've been doing so far has been just sticking with one compound at a time. This is the first time we actually have two different compounds. So that means that we're going to have to do this, the A and B situation here, because we have two different compounds. But everything else stays the same in terms of our setup. I always start with what I have. I have 20 moles of HCl. That's still my given. Okay, nothing's changed there. I still want to write what I'm looking for. So how many moles of SiCl4? How many? That's a big hint about what you're looking for. So way over here, I'm going to put moles of SiCl4. Silicon tetrachloride there. Okay. Then Snoop Dogg, drop it like it's hot. Mole HCl. All right. So I've got what I have. Way over here, what I want. Drop it. What I have, what I want, drop it. What I have, what I want, drop it. All right, now I need to look at my little graphic organizer. Here I am at moles of my first compound. I'm at moles of HCl, right? So here I am at moles of A. Just whatever compound is mentioned first, that's the one I'm calling A. I want to get to moles of something different, moles of B, basically, the other compound. The only way I can do that is right here. I'm at this mole. I want to get to moles of something else. Where do I get those values from? Mole ratio from balanced equation. What that means is I have to actually look at my balanced equations to figure out which number goes where. So here I have moles of HCl. I find my HCl up here. There it is. There's my HCl. Right here, it tells me I have 4 moles of HCl. On top, I want to go to a different type of mole. I want to go to mole SiCl4. Again, you're allowed to do moles of one thing to moles of another thing from the balanced equation. So on top, I'm going to put moles of SiCl4. Notice I didn't automatically put in a number. I have to get that number from the balanced equation. So I got the 4 from the balanced equation. I'm also going to get the SiCl4 from the balanced equation. In this case, it's a 1. So I double-checked Snoop Dogg, helped me to cancel out my units. I have moles of SiCl4, and that is exactly what I want, so I'm ready to solve. Same steps as all the other ones. 20 times 1 divided by 4. So I don't need to put this one in my calculator. 20 times 1 is 20, divided by 4 is going to give me 5 moles of SiCl4. Sorry for the left-hand smudge. 5 moles of SiCl4. Okay, now let's set up another one. Again, I've already balanced it for you. So it's just another problem. I've already balanced it. If you need more help with balancing, look at my other videos. Same 3 steps. What do I have? So let's read it. How many moles of CO2 are produced if you react 18 moles of CO? Sounds like that's my given, but I also notice I've got 2 different compounds. CO2, carbon dioxide, is different than CO, carbon monoxide. Okay, so that tells me I'm going to have to use this crossover between A and B. This is the only place I can go to get from A to B. All right, so starting with my given, 18 moles of CO. Second step, what do I want? How many moles of CO2? That's my unknown. Third step, drop it like it's hot. Moles of CO come down here. So again, using my graphic organizer, I'm at moles, so I'm right here. I want to go to moles of something else, so I have to go this way because otherwise I would have gotten to grams or particles. I don't want grams or particles. I want moles of something else, so here I am from the balanced equation. So I'm going to look up my moles of my CO, right there, 3, and my moles of the other thing I want, moles of CO2, from my balanced equation, in this case, also a 3. My moles of CO cancel. I'm left with moles of CO2, and that's exactly what I want. I'm ready to solve. 18 times 3 divided by 3. Again, I don't need a calculator for this one. It's okay if you do, but that's just going to give me 18. And here's my units, whatever's not crossed out, moles CO2. That's how you do the mole-to-mole ratio. I hope that helps.